Hey, what's going on, guys? Let's do this problem right here. The question is asking 32 grams of C2H6 is placed in a container with 39 grams of oxygen gas. 28 grams of CO2 are collected at the end of this reaction. Identify the limiting reactant, calculate the percent yield, and determine the amount of excess reactant that remains. So let's see how we can do this. So first of all, we have to write the balance equation for this one. So this is the combustion reaction. So this is going to be C2H6 plus O2. That's going to produce. Okay, let me increase thickness. Okay. Okay, C2H6 plus O2. That's going to produce CO2 and H2O, right? So in this combustion reaction, we always balance the carbon first. Here we have two carbons, so we put 2 in front of this, and then we balance the hydrogen. So here we have 6 hydrogen, and this is going to be 3 hydrogen, 3 right here. So this is going to be 6. Now finally oxygen, right? So oxygen, here we have 4 right here, and 3, 7. Here we have 2. So if I put 7 by 2, this will become 7. But we don't want the fraction. We always avoid the fraction in a reaction equation. So let's multiply everything by 2 to get rid of this 7 by 2 thing, right? So let's multiply everything by 2. So if I multiply everything by 2, this is going to be 2C2H6 plus 7O2, and on the other side we have 4 CO2 and 6 H2O, and this is the equation we are going to use. So this is unnecessary, right? And let's do the first question. The first question is asking to identify the limiting reactant, and here they have given 32 grams of C2H6 and 39 grams of oxygen gas. So in this kind of problem, if they give these grams right here, the first thing we have to do is we have to convert them into moles. So how we can convert them into moles? We simply divide this one by its molar mass. So if I divide the C2H6, so we have 32. First do the C2H6, so 32 grams of C2H6 multiplied by 1 mole. In 1 mole we have, so the molar mass, that is for C2H6 30.068. So in 1 mole of C2H6 we have 30.068 grams of C2H6. So this is the ratio we are going to have. And also, if you notice, gram C2H6, gram C2H6 cancels, and that's going to give us the unit of mole. So that's the important thing. And after we calculated the mole, what we do, first we are trying to calculate the mole, right? So that's what we are trying to calculate. So let's calculate this one. So this one gives us 1.064 moles of C2H6. So now let's calculate the moles of oxygen. So they have given 39 grams of oxygen gas is right here. So 39 grams of O2 multiply by its divide by its molar mass. So it's going to be 1 mole O2 has 32 grams of O2. So in 1 mole we have 32 grams of O2. So if you notice here also gram cancels, and we will be left with mole. And if you calculate this one, this will give you 1.219 mole. And to find the limiting reactant, what we have to do, we select the coefficients and divide these values by its coefficients. So for C2H6, 2 is the coefficient, right? So divide by 2, and here for O2, 7 is the coefficient. So we divide this one by 7 and see which one has lowest value, and that's going to give us the limiting reactant. That's going to be the limiting reactant. In this case, the first one gives us 0.532, and the second one comes out to be 0.174. And if you notice, oxygen has the lowest mole per coefficient ratio, so this is going to be our limiting reactant. So this is our limiting reactant. So this answers the first question, identify the limiting reactant, and that's oxygen. And the second question is asking, calculate the percent yield and determine the amount of excess reactant that remains. So calculate the percent yield, that's the second question. To find that one, we have to know how much CO2 is produced. Like they have given this 28 grams of CO2 are collected, so this is our actual yield. So this is actually we are getting from this experiment, right? Actual yield. But to calculate percentage error, percentage yield, we have to know this is the percentage yield is equal to actual yield over theoretical yield multiplied by 100. So we have the actual yield, but we have to find the theoretical yield. Let's see how we can find the theoretical yield. To find the theoretical yield, we always use the limiting reactant. And first thing we find the mole. But here we already found the mole already. That's 1.219 mole of O2. So this is our O2 is the limiting reactant. We already found it. So we are using mole of O2. And then what we do, we just simply multiply this one by the mole ratio. So we are trying to find the how many moles, like in one, if you use 1.219 mole of O2, how many moles of CO2 is produced. That's what we are trying to find, right? To find that one, what we do, we just use the mole ratio. So here in front of this 4, so this is 4 moles of CO2. So whatever we are trying to find, that's going to be on top. Here we are trying to find CO2, so that's going to be on top. In this case, the bottom we are going to have the O2 moles. It's 7 moles. So we have 7 moles of O2, and in the top we have 4 moles of CO2. So this is going to give us the moles of CO2 that is produced. But we want to know what is the grams of CO2 that is produced. So that is going to be the percentage. That's going to be the theoretical yield, right? So to find that one, what we can do, so since we have the mole, if we multiply the mole by molar mass, that's going to give us the weight mass. So we have to know what is the molar mass of the CO2. So here, if you find this one, that one gives us 44.01 gram in 1 mole. So this is CO2's molar mass, and if you multiply by this one, you will get the gram that is produced. So if you notice, if you calculate this one, that will give you 30.65 grams of CO2. So this is what actually, this is what theoretically, so this is the maximum amount of CO2 that can be produced from this experiment. But the value that is produced is 28 grams. So this is highest amount is always theoretical yield, because actual yield never exceeds the theoretical yield, and whatever we calculated, this is our theoretical yield, right? So percentage yield, that's what we are trying to find. That's going to be 28 grams, that's our actual yield, divided by 30.65 grams, that's our theoretical yield, multiplied by 100. And that's going to give us the percentage yield. So if you calculate this one, you will get 91.35 percentage, and this is the theoretical, this is the percentage yield, and that's the answer for the second question. Let's do the third question. Determine the amount of excess reactant that remains. Okay, so first things, to find this one, what we have to do, first thing we have to calculate the, so here we know this is limiting, oxygen is limiting, so C2H6 is is going to be the excess, right? So we are using O2 and C2H6. So if one is limited, other one is going to be excess. So we have to know, like when we use to burn, like to use all of these mole, we have how many mole? 1.219 mole. To use all of these moles of O2, how many moles of C2H6 is required? That's what we have to calculate. And that's the first thing. So to calculate that one, what we have to do, we simply take this mole of O2, that is 1.219 mole O2, and we multiply by the mole ratio of C2H6 and O2. So whatever we are trying to find, that's going to be on top. Here we are trying to find the C2H6 mole 2, right? So that's C2H6 mole. So that's going to be on top. So this is going to be 2 moles of C2H6. In the bottom we are going to have the moles of O2. So here that is 7. So this is the mole ratio, 7 moles of O2. And from this one you will find out how many mole it requires to finish, how many moles of C2H6 it will require to finish all these moles of O2, right? So that's what you will find. But we want how many grams of C2H6 is needed to use all of these moles of O2. So to find that one, what we do, since we have the mole right here, we simply multiply this one by molar mass of C2H6. So if you find the molar mass of C2H6, that will be 30.068 gram in 1 mole. So this is our molar mass of C2H6, and if you calculate this one, you will get 10.40 grams of C2H6. So if you use 30 to 39 grams of oxygen gas, 10.4 gram C2H6 will be used. So these values will be used during this reaction. So whatever the thing that is left is going to be the excess. Here we have totally 32 gram and this one is used. So 32 gram minus 10.40 gram, and this is used. Whatever value left is going to be the excess. So the excess amount is going to be, if you calculate this one, that will give you 21.53 grams of C2H6. And this is the excess amount of C2H6 we are going to have after the reaction occurs. And that's how we do these kind of problems. I hope you guys like this video. See you next time.